Good evening, students.
Good evening, sir.
How are you guys? Is the exams done?
Friday last exam, sir.
What exam tomorrow?
Biology I have, sir.
Okay, optional. Few are biology, few are some other economics and all like that. Anyway, so today we are going to discuss some special series. We are having not much special series. We are having very few. Some of the squares up to n terms, some of the cubes up to n terms. That's it. And after that, this sum of the square, sum of the cubes must be learned. Why? What is the necessity to learn this thing? This sum of the squares and sum of the cubes will be useful in calculus for us. There is a small concept called integration by numerical methods. Every year, 2 years back, every year they will ask one essay question from that in board exam. From past 2 years, things are changing. That's the reason I can't say whether they will ask for next year. But every year they're asking one essay question from that concept. That is called, the topic name is called integration by numerical methods. Integration by numerical methods. So there, if you know how to do sum of the cubes, sum of the squares, then only it will be easy to solve that question. And it is not for 1 mark or 2 marks. I think it's 6 marks question or 5 marks question. One question carry. So, and it is not only for that, and who is attending entrances, this concept is little much important for us. Yeah. So today we are going to see some of the n terms for special series. We already done one out of these. There are 3 series we are going to learn here. One is sum of the n terms with power 1. Sum of the n terms with the power 1. So the first series is 1 plus 2 plus 3 plus 4 plus and so on up to n. This will be sigma n power 1 or sigma n power 1, where n is equal to 1 to n. 1 to n. So this is a symbol, summation symbol. This symbol sigma is representing summation symbol. Suppose if n is equal to 1 to 10 means you are going to add 1 to 10 instead of representing 1 to 10. If I'm asking you to write 1 to 100, sum of numbers from 1 to 100 is n is equal to 1 to 100 n power 1. This will give 1 plus 2 plus 3 plus and so on up to 100. So this is very simple pattern. Why? 1 comma 2 comma 3 comma 4 comma and so on up to n will represent the numbers are in AP. The terms are in AP. With a initial term is 1. Common difference is also 1. We know SN formula is what, guys? What is the SN formula? SN is equal to what? N by 2 into A plus L. Am I right or wrong?
Yes, sir.
Or what is another one? If I don't know the last term, what is the formula?
So n by 2 into 2a plus n minus 1 into d.
A plus n minus 1 into d. You can use any formula. Here I know the first term and last term. N by 2 into A plus n, where A is equal to 1 here. So this is n into n plus 1 by 2. It's very simple to write sum of n terms. Sum of n terms whose power is 1. Sigma n is equal to 1 to n power 1. That is 1 plus 2 plus 3 plus 4 plus and so on up to 5 can be written as n into n plus 1 by 2. This is my first expression. Suppose sum of the n terms, sum of the squares of the n terms, that is 1 plus 2 plus 3 plus 4 plus and so on. But here it is square. 1 square plus 2 square plus 3 square plus 4 square and so on n square. How I can represent this one? sigma n square, where n is equal to 1 to infinity. Sorry, 1 is equal to n to n, or where n is a natural number. So how we will solve this one? Students, we are going to use the basic algebra formula here. Try to recollect what is the expansion of k cube minus k minus 1 whole cube. If I'm expanding, what I will get, guys? K cube minus k minus 1 whole cube is how much? K cube minus 3 into k square into 1 plus 3 into k into 1 square minus 1. So here k cube minus k square, k cube plus 3k square minus 3k plus 1. So this will be equal to 3k square minus 3k plus 1. 3k square minus 3k plus 1. So I am taking this expression. To find out the sigma n square value. We know k cube minus k minus 1 whole cube can be written as 3k square minus 3k plus 1. If k is equal to 1, I will get 1 cube minus 0 cube will be equal to 3 into 1 square minus 3 into 1 plus 1, which is equal to how much? What you will get, guys? We can keep like this. If I'm substituting k is equal to 1. If I'm substituting k is equal to 2, what I will get? 2 cube minus 1 cube here. Here 3 into 2 whole square minus 3 into 2 plus 1. When k is equal to 3, I will get 3 cube minus 2 cube. Here I will get 3 into 3 whole square minus 3 into 3 plus 1. If k is equal to 1, what is the expression you will get? Students, if k is equal to 1, what is the expression you will get? If k is equal to 1, what is the expression you will get? Students here, n cube minus n minus 1 whole cube is equal to 3n square minus 3n plus 1. So this is the n series. This is one, this is second one, this is third one, this is up to n times. Now I'm adding all the things. What will happen? 1 cube will cancel, 2 cube will cancel, like 3 cube will cancel, n minus 1 cube will cancel. Finally, we'll get n cube minus 0 cube will be equal to, the first is like 3 into 1 square plus 2 square plus 3 square plus 4 square plus and so on, n square. The second term is minus of 3 into 1 plus 2 plus 3 plus and so on up to n. The last one is 1 plus 1 plus 1, n times you are adding. So it is n. 1 plus 1 plus 1, you are adding n times. So it is n. So now I want the expression of this one. I want to calculate how much value it will be. So now this can be written as 3 into sigma n square minus 3 into sigma n plus n. We know I need the sigma n square value. 3 into sigma n square minus 3 into sigma n is n into n plus 1 by 2. N into n plus 1 by 2 plus n. So take what are the terms you want, keep it one side, rest of the things are one side. So keep this one is here and take these two terms are this side. N cube plus 3n into n plus 1 by 2 minus n is equal to 3 sigma n square. So if I am taking LCM and doing all the works, what will happen here? What I will get, guys? N cube plus how much you will get? Two n cube.
3n square plus 3n.
N square plus 3n minus
Minus
2n divided by 2 is equal to 3 sigma n square. From here, sigma n square will be equal to 2n cube plus 3n square minus plus n divided by 6. So to write in a simplest form, I'm taking n common first. If I'm taking n common, I will get 2n square plus 3n plus 1 divided by 6. Again, this quadratic equation, check whether it can able to factorize or not. Yes, the product should be 2n square and sum should be 3n. Yes, it can able to factorize. N into 2n square plus 2n plus n plus 1 by 6. This will be n into, if I'm taking 2n common, n plus 1, 1 common, n plus 1 divided by 6. If I'm taking n plus 1 common, n into n plus 1 into 2n plus 1 by 6 will be equal to sigma n cube, where n is equal to 1 into 1 to n square. 1 square plus 2 square plus 3 square plus 4 square and so on up to n square. This is the expression for sigma n square, sum of the squares of the n terms. Sum of the squares of the n terms. Hope you are clear what I done. So this strategy, why I am explaining particularly, this can be applicable for any summation formula. Even if I want to calculate sigma x power 6, sigma n power 6, 1 power 6 plus 2 power 6 plus 3 power 6, also I can use this one. Even if I want to add summation for 10, this strategy I can use. Whatever strategy I applied, the same strategy I have to use here. But only the complication is you have to apply binomial theorem here. Binomial theorem, we are not at came to the binomial theorem. Now, one more formula we are going to discuss. Sigma n cube. That meaning is 1 cube plus 2 cube plus 3 cube plus 4 cube and so on. N cube is how much? What is the simplest form of this one? How to calculate the sum of the cubes of the n natural numbers? Here also same. Take k plus 1 whole power 4 minus 0, k power 4 formula. Write the expression for this. What I will get, guys, here? K plus 1 whole power 4 minus k power 4, or k power 4 minus k minus 1 whole power 4. Anything is fine. It's your wish. With respect to any expression, you can start and you can start substituting k is equal to 1. But here you can start substitution k is equal to 1, 2, 3, 4, or you can start from 0, 1, 2, 3, 4. It's your wish. What is the expansion of k plus 1 whole power 4? How to do k plus 1 whole power 4? Students, I can do like this. What you will get? K plus 1 whole power 4 is how much? K plus 1 whole square again minus k power 4. So this is k square plus 2k plus 1 whole square minus k power 4. What is the expansion of a plus b plus c whole square? A square plus b square plus c square, correct? Plus 2ab, that is 4k cube, 2bc 4k, 2ac, that is 2k square minus k power 4. K power 4, k power 4 cancel. 4k square, 2k square is there. Finally, I'm getting 4k cube plus 6k square, because 4k square plus 2k square is 6k square, and 4k plus 1 square is 1. This is the expression for k plus 1 whole power 4 minus k power 4. I'm starting with k is equal to 1. If I'm starting with k is equal to 1, what I will get here? 2 power 4 minus 1 power 4. That will be equal to 4 into 1 cube plus 6 into 1 square plus 4 into 1 plus 1. If I'm taking k is equal to 2, 2 power 2 minus, sorry, 3 power 2 minus 2 power 2, which will be equal to 4 of 2 whole cube plus 6 of 2 whole square plus 4 of 2 plus 1. Up to n terms if I'm writing, for example, if I'm taking in place of k, if I'm taking n, k is equal to n plus 1 whole power 4 minus n power 4 is equal to 4n cube plus 6n square plus 4n plus 1. If I'm adding all these things, same as here, 2 power 4, 3 power 4, 2 power 4, 3 power 4, 3 power 4. Here n power 4 will be. Finally, I will get n plus 1 whole power 4 minus 1 power 4 will be equal to, first if I'm adding cubes, 4 into 1 cube plus 2 cube plus 3 cube plus 4 cube plus and so on, n cube, and plus 6 into 1 square plus 2 square plus 3 square and so on, n square. And the third term is summation of n numbers, 1 plus 2 plus 3 plus 4. 4 into 1 plus 2 plus 3 plus 4 plus and so on up to n. The last one is 1 plus 1 plus 1 n times. This can be write in the short form sigma n cube plus 6 sigma n square plus 4 sigma n plus n. So this will be n plus 1 whole power 4 minus 1 power 4. N plus 1 whole power 4 minus 1 power 4. So how will solve this one? I need only sigma n cube formula. So I have to bring all these things this side. 4 sigma n cube plus 6 sigma n square means what? What is the sigma n square formula? N into n plus 1 into 2n plus 1 by 6. Sigma n formula is what? N into n plus 1 by 2 plus n. This is equal to n plus 1 whole cube. N plus 1 whole cube, whole power 4 minus 1 power 4. This will be equal to 4. How much? This is equal to how much? 4n cube plus 6n square plus 4n plus 1. Am I right, guys? Do you agree? Correct or not? So I want 6 cancel. This will be 4 sigma n cube n into n plus 1 into 2n plus 1. So n into n plus 1 into 2n plus 1. How much you get? N into n plus 1 into 2n plus 1. N into 2n square plus 3n plus 1. This will be 2 times. This is 2n square plus 2n plus n. Solve this question and let me know how much you are getting. Two n cube 3n square plus n plus 2n square plus 2n plus n. Out of all these deductions, what I will get finally, students? What is the final equation you will get? Out of all these cancellations and everything. N plus 1 whole power 4 minus 1 power 4. Guys, here with a mistake. This is not 4n cube. N plus 1 whole power 4. What is the expression you got? N plus 1 whole power 4. K plus 1. N plus 1 whole cube. Here you have to keep n plus 1 minus 1 cube plus 1 whole power 4. 4k cube. K is equal to n. N plus 1 whole power 4 expansion you have to do, no option for us. The expansion of n plus 1 whole power 4 is how much? N plus 1 whole power 4 expansion. Here we done. N plus 1 whole power 4 expansion. N square plus 2n plus 1 whole square. Again, n power 4 plus 4n square plus 1 plus 4n cube plus 4n plus 2n square plus 1 minus 1. 1 cancel. So finally, I will get n plus 1 whole power 4 minus 1 power 4 will be equal to n power 4 plus 4n cube plus 6n square plus 4n plus 1. This is the option you have to write here. N power 4 plus 4n cube. This is not right option. Sorry, guys. This is equal to n power 4 plus 4n cube plus 6n square plus 4n. This is that. Why this is that? 1 will cancel here. But why I got extra 1? This is not extra 1. AB, BC, CA. CA means AB is n cube. BC means 4n. AC means 2n square. Yeah, this won't come. That's it. So if I'm doing all these things, finally I will get like this. 4 times sigma n cube will be equal to n power 4 plus 4n cube plus 6n square plus 4n minus how much? 2n cube minus 3n square minus n, and this one n will be there, minus 2n square minus 2n minus 10. So what are things will cancel, guys? Out of all these things, what are things will cancel? Finally, I am getting n power 4 is there, 4n cube is there, 6n square, 2 plus 2, 4. 4 minus 3 minus 7. 6 minus 7 minus n square is coming. Check anywhere we done any mistake. It should be plus n square.
Sir, it's minus 2n cube.
Minus 2n cube, yeah. So minus 3n square minus 2n square is 5. So this will be, then it will be n power 4. N cube 4 minus 2 is plus 2n cube. 6 minus 3 minus 2 is plus n square minus 3n minus 4n plus 4n. So 0n. So finally, I am getting an equation like this. 4 times sigma n cube will be equal to n power 4 plus 2n cube plus n square. If I am taking n square common first, I will get n square plus 2n plus 1. It is n plus 1 whole square formula. N square into n plus 1 whole square. So from here, sigma n cube is n square into n plus 1 whole square divided by 4. Or I can write as n into n plus 1 by 2 whole square. I can write like this, guys. Is there anything wrong in this? Which is equal to summation of n numbers whole square. Even sigma n is what you are getting, sigma n into n plus 1 by 2 only now. Check whether you are getting that relation is or not. Suppose if I am taking 1 plus 2 plus 3, how much I am getting? 2 plus 1, 3. 3 plus 3 is 6. This is sigma n. So sigma n whole square is 36. Suppose if I am taking 1 cube plus 2 cube plus 3 cube. This is 1 plus 8 plus 27. So the answer is 29 plus 8. 37 is coming. Check where we done the mistake. It should come sigma n whole square only now. Yeah, 36 only. Sorry. 1 plus 8 is 9. 9 plus 27 is 36, which is equal to sigma n whole square. Both are same. So this is one relation we can develop between sigma n and sigma n cube. Like this, we can do for sigma n power 5 also. Shall we proceed some numerical, students, based on this? These derivations are actually not required. You have to remember the formulas of n cube and n square. But why I am giving the derivations for particular numericals? If you know the strategy, how I calculated the formula, then it will be easy to do that particular kind of numericals. Students, is it clear? Guys,
Yes, sir.
there? Yeah. What is the purpose of the special series? Don't expect simply they will ask what is a 1q plus 2q plus 3q formula. What are the various kind of numericals we may face? Our aim is whatever the series they are giving, we have to bring it to either sigma n formula or either sigma n square formula or sigma n cube formula or either AP series or either GP series. These are the 5 options we are having. Whatever the series you are having, you have to split the series by doing some algebraic operations, any one of these 5 series or a combination of these 5 series. So where it will be helpful for us? Find the sum of n terms. The relation is like this: 5 plus 11 plus 19 plus 29 plus 41 and so on. So how I can relate? Check whether it is in AP. 11 minus 5 is 6. 19 minus 11 is how much? 7. 29 minus 9 is, see, this difference is 6. This difference is 7. And the difference is 10. Again, the difference is somewhat different. It's not in 8. Yes?
The difference is 8, sir.
5 minus 11, man. This is 8. This is 10. And what is the difference here? 29 plus. So anyway, it is not, but the difference is increasing by 2, 2, 2, 2. Correct?
Yes, sir.
So 11 by 5 is not equal to 19 by 11, is not equal to 29 by 11. You see, 11 by 5 is prime factors, 19 by 11 also primes, 29 by 9, 11 also primes. But what is the difference between these two? It is 12. Next, 41 plus 14 is the next term. I can write like this. But this will be helpful for to do anything? No, it won't be helpful for us. It's just adding all the, not even prime numbers also, because between 5 and 11, 11 and 19, there is a 2 prime numbers, 13 and 17 is there. That is also can't be. But I found a relation, they are adding in such a way, 2, 2 increasing for each and every addition. So here 6, here 8, 8, 10, 8, 12. Again, I can expect 14 after 41. I may get 41 plus 14. So my SN is 5 plus 11 plus 19 plus 29 plus 41 and so on. So I am writing last few digits. This is given an minus 1 plus an. Why I am doing this one? I am taking Sn is equals 5 plus 11 plus 19 plus 41, sorry, 29 plus 41 and so on, plus under this a n minus 2 plus a n minus 1 plus a n. If I am subtracting both, what I will get? If I am subtracting both, what I will get? Or take this 5 this side, this is Sn minus 5, and subtract these two series, what you will get? I'm subtracting Sn minus 5 and Sn value. What I will get? I will get like this. Sn minus 5 minus Sn is equal to 11 minus 5. What is 11 minus 5? 6. 19 minus 11, 8. 29 minus 19, 10. 41 minus 29, 12. And so on. Here, finally, what I will get? An minus, so what I will get here? Plus and so on up to n minus 1 terms minus an. Understood, guys, what I'm doing here? So Sn cancel, this will be equal to 5. Sn cancel, this is equal to 5. I want an value because it is sum of, I'm trying to calculate the an. Take this an this side and 5 this side. So my an is equal to 5 plus, what is this formula? 6 plus 8 plus 10 plus 12 and so on n minus 1. This is a series which is in AP whose first term is 6 and the last term is n minus 1. What is the formula? N into n plus 1 by 2. That is the formula. Here n minus 1 terms are there. The series is starting from 6. Common difference is 2. N minus 1 by 2. 2 into 6 plus n minus 1 of common difference is 2. Can I write like this? Is this correct? Students, applying the Sn formula for AP. This is 5 plus n minus 1 by 2. 12 plus n minus 2 into 2. When I'm solving this one, what I will get? This is 5 plus n minus 1 by 2 into 12 plus 2n minus 4. This is 5 plus n minus 1 by 2 into 8 plus 2n to 4 times to 2 times to 1 times. This is 5 plus n minus 1 into n plus 4. This is your an value. This is your an value. Now, if you substitute n is equal to 1, n is equal to 0, when substituting n is equal to 0, what I am getting first term is, this is your an value. 5 plus n minus 1 into n plus 4. So, which is equal to a quadratic equation n cube, sorry, this is n square, n minus 1 into, this is into n plus 4. This will be n square plus 3n. So 5 plus n into n is n square plus 4n minus n minus 4. So n square plus 4n minus n is plus 3n, 5 minus 4 is plus 1. This is an. So if I am substituting n is equal to 1, you will get a1. If I am substituting n is equal to 1, how much I will get? A1 is equal to 1 plus 3 plus 1, 5. N is equal to 2. How much I will get? A2 will be equal to 4 plus 6, 10, 10 plus 1, 11. So if n is equal to n, your an is equal to some expression I got, n square plus 3n plus 1. If I'm adding means, that means what? Sigma an, where n is equal to 1 to n. This will be equal to 5 plus 11 plus and so on an. Or this whole equation can be replaced by sigma n is equal to 1 to n square plus 3n plus 1. This will be sigma n square plus 3 times sigma n plus sigma one. You are adding n times, so you will get sigma n is equal to 1 to n 1. That means you are adding 1 n times. This meaning is adding 1 n times. Sigma n square value is n plus n into what is sigma n square value, guys? N into n plus 1 into 2n plus 1 by 6. Sigma n is 3 into n plus 1 by 2 and n. Sigma 1 is n. Till what terms you are adding? Sigma 1 means you are adding 1 plus 1 plus 1 plus 1 plus. Sigma n is equal to 1 to 10 means you are adding 1 10 times. You are adding 1 20 times like this. So out of this, how I can do this calculation? What are the things I can take common? N into n plus 1 I can take common. Then I will get 2n plus 1 by 6 plus 3 by 2 plus, no, I can't get, plus n. So anyway, you have to multiply. The LCM is 6, 2n plus 1 plus 9 plus n. So what is the final answer, guys? What you will get final answer? Anyone can give the final answer? What I can expect the final answer? N into n plus 1 into, this is 2n plus 10 by 6 plus n. This is n into n plus 1 into n plus 5 I am getting. 1, 2, 3, 3 is 9, 9 plus 1, 10. Somewhere we are missing, guys. N plus 1 into n plus 5, 2 times by 6 plus n, 2, 3 times. Now if I am adding 3n to this, n into n plus 1 into n plus 5 plus 3n divided by 3. So further, if I am taking n common, n plus 1 into n plus 5 plus 3. If I am multiplying and adding 3 and taking the factors again, might be we can do that part in beginning of itself. You can leave it like this, or n into n plus 2 into n plus 4 by 3. You will get like this, multiply and add 3 and take the factors again. So this is how we have to do. Algebraic calculation is very much important. Keep it in mind, guys. I'm going textbook questions. Let's see. The textbook questions, solved questions only a little bit tough, but if you go the questions, exercise questions, it is little pretty simple. It's not too much tough. We'll see a few questions from this. This is the last exercise from this topic. So here there is nowhere related between one question and another question. Each and every question you have to think how I can make it as either n cube or n square or something. How you will do the first question, guys? 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5 plus. How we can relate this question? This series can be written as 1 into 2 plus 2 into 3 plus 3 into 4 plus and so on. How I can write this one, guys? N minus 1 into n or n into n plus 1, which is your comfort, where n is equal 1 to n. Or you can take in, if we are too much confusing, sir, how sigma n is equal to n to 1. This can be written as k into k plus 1, where k is equals 1 to n. K is equal to 1 to n. If I am substituting 1, I will get 1 into 2. If I am substituting 2, 2 into 3. Substituting 3, 3 into 4. If I am substituting n, n into n plus 1. N into n plus 1. See, this is a first term, this is a second term, this is a third term. If I am substituting n here, this is the nth term. He's asking, and so on, sum of the n terms. So this can be written as sigma k into k plus 1, where k is equal to 1 to n, because n terms. This is sigma k is equal to 1 to n, k square plus k. So this is equal to sigma k square, where k is equal to 1 to n, plus sigma k is equal to 1 to n k. Sum of the n terms, sum of the n square terms. Sum of the n square terms is how much, students? Sum of the n square terms, n into n plus 1 into 2n plus 1 by 6. Sum of the n terms, n into n plus 1 by 2. If I am taking n into n plus 1 by 2 common, I will get 2n plus 1 by 3 plus 1. If I am simplifying this one, n into n plus 1 by 2, 2n plus 1 plus 3 by 3. This will be n into n plus 1 into 2n plus 4 by 6. This again I am writing as n into n plus 1 into, if I am taking 2 common, n plus 2 into 2 divided by 6, 2 3 times. So I am getting answer n into n plus 1 into n plus 2 by 3. Hope you are clear what I done here. Students, is it clear what I done? Guys, please respond. Yes or no, or something not clear, clear.
Yes, sir.
So we'll move to the next question. Yeah, please solve this question, guys, with the help of the same data, same method. Another thing is you have to frame a series. That is the important thing here. Framing the series, that should be done by us only. Framing the series, how we will get. Looks like almost same as the question number 1 only. Here, how I can frame a series? The given is sum of the first 3 terms. Next to 3, next to 3. This is looking like 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus next is 4, 5, 6. Then k into k plus 1 into k plus 2. This is first term, this is second term, this is third term, this is nth term, where k is equals 1 to n. When substituting n, n into n plus 1 into n plus 2. This can be written as sigma k into k plus 1 into k plus 2, where k is equal to 1 to n. Sigma k is equal to 1 to n. This can be written as k into k square plus 3k plus 1 plus 2. Again, this can be written as sigma k is equal to 1 to n k cube plus 3k square plus 2k. So this again I can split into sigma k is equal to 1 to n k cube, sigma n is equal to 1 to k 3k square plus sigma n is equal to 1 to k 2k. Now we know the formula for k cube formula, sigma k cube, sigma k square, sigma k. K cube formula is what, students? What is the cube formula? N into n plus 1 by 4. For this it is whole square. I'm taking 4 here. 3 times, what is the k square formula? Sigma k square is n into n plus 1 into 2n plus 1 divided by 6 plus 2 times n into n plus 1 by 2. Now I have to simplify this one. Each and every case n into n plus 1 is common. Each and everywhere. This is 3 2 times. I'm cancelling. This is 2 2 cancelling. I'm taking n into n plus 1 common. If I'm taking n into n plus 1 common, n into n plus 1 by 4 plus 2n plus 1 by 2 plus n into n plus. Now I'm getting the equation like this. So from here, I have to take LCM. My LCM is 4. N into n plus 1 is n square plus n plus 2n plus 1 plus 1. So I'm getting an equation of n into n plus 1 into n square plus 3n plus 2 divided by 4. Is there any factorization you can do, guys? This one? Factorization? Yes, there is a factorization for this. Is it
X
correct?
plus 1 into x plus 2.
N plus 1 into?
N plus 2.
Again, n plus 1 is coming. Should come n plus 2 into n plus 3. Check where, anywhere we done any mistake. Go through the question, guys, once. N into n plus 1, I'm taking common. 2 times k, 3 times k square. Yeah, the mistake is LCM. LCM is 4 now, so this will come 4. So this whole thing is 5 now then. This is, this step is wrong. This whole step is wrong. Taking LCM, I done wrong. 1 second, guys. Yeah, if I'm taking LCM, n square plus n plus 2 times 4n plus 2 plus 4 times 4. N square plus n, 4n plus 2, 2 times of whole thing. This is 4 times by 4. This will be n square 4n plus n, 5n, 2 plus 4 is 6. Now it is ready to take the factorization. This is n into n plus 1 into, this can be written as n square plus 3n plus 2n plus 6 by 4. So n into n plus 1 into, if I am taking n common, n plus 3 into, if I am taking 2 common, n plus 3. Finally, I will get an expression of n into n plus 1 into n plus 2 into n plus 3 divided by 4. Is it clear, guys, what I'm saying? What is the answer for previous question? Previous question is 3 divided by 3. If it is 2 terms, 3. If it is 3 terms, 4. If I'm writing 1 into 2 into 3 into 4 plus 2 into 3 into 4, anything you can expect? With the help of these previous two things, I can say that is n into n plus 1 into n plus 2 into n plus 3 into n plus 4 divided by 5. I can say like that. That we will see in mathematical induction, how I can prove those kind of things. Next question. Who is going to explain this question, how to solve? Any ideas, please, students? Expecting some kind of ideologies from your end. Students, please respond. Ansini, anyone? Raghav, Suprajit, Shriya. My question is 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus and so on. How I can relate this question to here? I can write, see here, what is the relation here? This is 1, this is 3. When it is 2, this is 5. When it is 3, this is 7. What is the difference between 1 and 3? 2. Here also, here the difference is 3. Here difference is 4. Suppose if I'm writing like this, this can be written as 2n plus 1 into n square. If n is equal to 1, what I am getting? 3 into 1 square. If n is equal to 2, what I am getting? 5 into n 2 square. If n is equal to 3, what I am getting? If n is equal to 3. Students, please respond. If n is equal to 3, 7 into 3 square. If n is equal to 4, what is the next term? 9 into 4 square. And so on. If n is equal to n, if n is equal to n, 2n plus 1 into n square. So this can be written as summation of k is equal to 1 to n, 2k plus 1 into k square. Then you will get this series. Now your job is easy. What I have to do next? Students, are you clear how I framed this equation? Guys, please respond.
Yes, sir, understood.
So again, same. Convert everything into either cubes or squares or something. So this will be 2k cube plus k square. 2k cube plus k square. This will be equal to 2 times sigma k is equal to 1 to n k cube plus sigma k is equal to 1 to n k square. This will be equal to 2 times sigma k cube is how much? What is the expression for k cube? N into n plus 1 whole square by 4 plus n into n plus 1 into 2n plus 1 by 2. 6, sorry. This is 6. This is 2 times. If I'm taking 1 by 2 common and as well as n into n plus 1 also common. If I'm taking n 1 by 2 into n plus 1, n into n plus 1, here 2n plus 1 by 3. This is half into n plus 1. Then after that, this calculation is up to yours. It's a basic algebra. N square plus n. This is 3n square plus 3n plus 2n plus 1. This will be 1 by 6 into n plus 1 into 3n square plus 5n plus 1. So how to factorize this one? Is there any way to factorize this one? Is it possible to factorize? Is it possible to factorize, guys? How to know whether I can factorize or not? By seeing the equation, how I will know whether it can be factorized or not? What concept you have to use to check whether it can be factorized or not? Students, the question is for you people only. Please, children. How I can say by seeing a quadratic equation whether I can able to factorize it or not? Anyone having any idea? It is a mind calculation. Anyone can give the answer. Raghav, any idea? Hansini, madam? The last question. After this, I will wind up the session. Anyone? Raghav?
Sir, I don't know.
If discriminant is a perfect square, then you can able to factorize. If discriminant is not a perfect square, you can't factorize straight away. Middle term can't be split if the discriminant is not a perfect square. I'm not talking about real or unreal. I'm talking about rational factors. If discriminant is a perfect square, there is a possibility of factorization. That is a keep in mind. If the discriminant, what is the discriminant here? B square minus 4ac. 25 minus 12, it is coming as root 13. Root 13 is a irrational. If it is irrational, means you will get the irrational roots. So I can keep the question. Final answer is n into n plus 1 into 3n square plus 5n plus 1 by 6. If discriminant is a perfect square, some number is coming 3 or 5 or 10 or something, then you can able to sit and factorize and keep it in a simplest form. Understand, guys, how to think to make it is a simplest form, where it will reflect. Might be this you are going to write MCQs that many places it won't reflect. When you're writing descriptive part, suppose if you got 99, there is a chance of getting 100. These are the places where they will reduce half mark here. So keep it in mind. How to make it quick. So, sir, same questions. What is the scope of, what is the possibility of asking in MCQs? In MCQs, how they will ask the same kind of questions? It's very simple. We are going to use the substitution method in MCQs, but that is not much suggestible for concept point of view. For concept point of view, we learn both. It's not so easy to complete the paper if you are going everything concept point of view. To score better, I'm giving. To score better only, I'm going to give the shortcuts. People will say marks won't be useful and all, but who is aspirant for the IITs and JEEs in India? If you go abroad, marks is not a much deal. They will look into the skill. But here, if you want to join a better thing, each and every half mark is also important for us. That's the reason I can't say marks is not much important for you people. If there is a possibility, gain the marks. But we should not get the marks by cheating. That's only the thing I am trying to say to you people. So I will explain a few questions, how to make it quickly like this. That means if it is MCQs pattern, how to solve this question instead of spending this much of time. What kind of questions I may face from the special series is a few questions we will discuss in tomorrow class. Next class might be this weekend. I'm planning to take classes if your exams is going to over. Hamsini, his exams is going to complete, or we will have Monday onwards.
Sir, exam get completed by Friday.
Then take 2 days breaks, man. Why I don't want to make you to compel like this. Next week I will take 1 or 2 extra sessions. We will complete the portions comfortably. At least we'll make a gap of 1 month or 1.5 months for your board examinations. When is your first terminal examination, Raghav? When you can expect?
Sir, like October end.
October end. Then we will target by first week of October itself. We'll complete the syllabus. Then we will go for each and every chapter's possibility of MCQs, how to solve within a short time. Okay.
Okay, sir.
Yeah, we'll meet in next class. Bye, everyone.
Bye, sir. Thank you.
Thank you, sir.
Thank you.